Voilà, donc, voilà, donc on va continuer nos travaux qu'on a commencé avant-hier. Hier, on a eu deux présentations très enrichissantes de la société SPIC HHDC de Chine. Voilà, donc on va continuer avec cette même société qui a beaucoup de choses à partager avec nous, beaucoup d'expérience à apprendre d'eux. Donc aujourd'hui, on a deux sessions à aborder. La première session va porter sur les énergies intelligentes intégrées. Donc, on aura une présentation sur ce sujet. Et le deuxième sujet qu'on va aborder, c'est les nouvelles énergies, le système de stockage d'énergie et de production d'hydrogène. Voilà, donc c'est les deux thèmes qu'on va aborder aujourd'hui. Et donc, sans plus tarder, je vais donner la parole au premier orateur, qui est M. Liu Kangfle, qui va nous faire une présentation sur les énergies intelligentes intégrées. Monsieur Liu, vous avez la parole, s'il vous plaît.
Yes, good morning.
Good morning.
Yeah, can you hear?
Yes.
Okay, let's start. To share my screen. Have you seen, Mr. Jacobo?
It is come. Yes, I can see. Yes.
Yes, the page down. It's not move. Let me try again.
Okay.
Now you can see.
I cannot see now. Try to share again. Yes, now I can see.
Not page is not done.
Now
It's
I
okay.
can see.
The page is done.
Yes, the page start.
It's okay.
Yeah, it's okay. It's moving.
It's moving. Yeah. Okay.
Yes.
Let's start.
But it is not show all page, huh?
Huh?
I'm not sure. Do you put it in the presentation mode? Because maybe some part of the page is hidden in the bottom.
Let me try. Let me try again. It's coming. The pad.
Yeah.
Stop. It's done.
Yeah, it's moving now.
It's moving.
Yes.
It's okay?
Yes.
Okay.
Okay.
Okay, let's start then. Good morning and good afternoon. My name is Liu Kangfei from China. I'm glad to meet you again. I work for our company named HHDC Huanghe Hydropower Development Corporation, which under SPEC, that is China State Power Investment Corporation. It's our group company. So today, my presentation is a subject of integrated smart energy. Talk about energy, it's smart. What is it? Let's see the following contents. There are 4 parts on content. They are first, the overview of integrated smart energy. The second is development background. The third is the typical scenarios and cases. The last is the business model. Let's see the part 1, overview of integrated smart energy. What is the integrated smart energy? The definition is based on the new generation of information technologies such as cloud storage, big data, Internet of Things, mobile and intelligence power system as the center can be closely covered with natural gas network, heating network, industry, transportation, and building systems. For horizontal, complementation of diversity sources of electricity, gas, heat, and renewable energy. And for vertical, high synergy of energy source, power grid, load, and storage, the 4 parts to form an energy service network of two-way interactive concentration and distribution of product and consumption for clean, low carbon, safe, and efficient energy. About definition, the key point is that complementary of diversity energy. Normally, we can call it as energy compensation or hybrid. It may be a little bit complicated. I think we are working for energy sector. It's not strange from us, even very close with us. We see the overview, this focus on energy source, power grid, load, and storage. The 4 parts, let's see the development strategic, how to integrate the smart energy project. First, look at the picture. This picture includes 4 aspects. First is the transformation measures on energy sites. Have PV curtain wall, roof PV, high efficient centralized cooling system. The second on energy storage side has PV energy storage, charging for car parking, and storage battery. Even the energy control, we see the control center and service center. The fourth is the energy supply network. The intelligent energy supply network included. What is the scope of the integrated smart energy industry? Clean heating, renewable energy heating, heat pump technology application, geothermal, intelligence, electrification, etc. The CCHP, it means combined cooling, heating, and power. The energy storage, power supply side, and use side peak regulation and frequency modulation project. It's called a fast regulator. The hydrogen energy use hydrogen from industry byproducts. The hydrogen from renewable energy we call green hydrogen. Hydrogen energy vehicles, hydrogen storage, and filling station. Replace coal, oil, and gas with electricity, power and transportation hub and services. Two-way, invent charging, discharging, V2G, we call the vehicle to grid, the charging station. The comprehensive utilization project of thermal power plant and nuclear power plant for heating, seawater, desalination, and so on. Industry chain collaboration projects providing comprehensive energy service to end use. This is the part 2, development background. The low carbon, environmental protection, energy conservation, and emission reduction promoted the energy consumption revolution. First, improve the comprehensive utilization efficiency of energy through technology progress. Promote and high quality development of energy industry through innovation, and reduce emission of greenhouse gases and pollutants. The second is guide and encourage clean energy development. The third, advocating low carbon and environmental protection and reduce emission and unreasonable energy consumption. Accelerating to form an energy-safe society to building a sustainable energy system. Establish diversified energy supply system. Promote the energy supply revolution. First, expand supply chains, such as accelerating exploration and development of domestic energy resources. Second, through establishment of state piping network cooperation. The construction of natural gas production, supply, storage, and marketing system has been accelerated to improve the proportion of natural gas and reduce the proportion of coal gradually. The third, it is necessary to speed up the transformation of energy production and consumption to provide clean energy such as hydrogen energy, renewable energy, including hydropower, biomass energy, solar and wind energy will be greatly replace fossil energy. The fourth is a strength construction of energy transmission and distribution network and facilities. And driver industry upgrading, promote the energy technology revolution. The first, launch a revolution to increase production of new energy. The second is a technology innovation to overcome the bottleneck problems in key technology and getting technological breakthrough. The third is use the new generation of information technologies, such as network, cloud computing, and big data, make the best use of a diversified and sustainable energy supply system. Fundamentally, solve the problems of unsustainable energy resources and ecological environment. Development of energy on fast track, the promoter, the energy system revolution. The first, innovation development in management, organization, and marketing operation mechanisms, increase competition and stimulate development. The second, clarify the boundary between the governmental supervision and market rules, break monopoly and force promoting marketing vitality. The third is reduce repeat construction, reduce investment and operating cost, ensure energy safe and stable supply. Let's see the energy security. Strengthen international cooperation in all-round way to achieve energy security and open conditions. First, ensure security supply of best energy, which is the biggest challenge The third is the second, promote upgrading of energy technology through international cooperation. The third, innovation technologies such as underwater oil and gas extraction technology, new energy reuse technique, etc. So that promote the development of global energy technology above mentioned. It's called Chinese approach. We see the part 3, the 2 big scenarios and cases of integrated smart energy. This section is the main point of this subject. We will see some of cases for examples of smart energy. See the arrangement. There are 4 catalogs and 24 2 big scenarios. There are 1 smart tone type. The catalogs has 4 2 big scenarios. And the industrial park has 8 scenarios and cases. And the buildings have 7, and the energy base have 5. Okay, following, let's look at one by one. The smart tone that have 4 scenarios and cases: smart city, smart cooling, and intelligent cooling, incremental distribution network. Let's read it. The facing the new and old city according to the requirements of the construction of new smart city, efforts will be made to solve the pain point and difficult problems such as large demand for energy, environmental protection requirement, and low comprehensive energy efficiency, combined with the smart buildings, transportation, information, and other means. An overall urban solution with energy security, sustainable production, environmental protection, energy conservation, and high efficiency will be created. Let's see the smart city. The introduction like this, the custom is the local government providing constructive, comprehensive energy and industry planning for development of new urban area. It's characterized by the development model led by planning, which will drive the project development, while the project will improve the depth of the planning. The smart cooling. The characteristics of resources and loads can be studied by taking the cooling area as the research object combined with the centralized cooling demand to solve problem of small-scale, low energy utilization, extensive operation and management. And unfavorable, the market ties and marketization and decentralized the cooling system. The overall solution of centralized cooling is provided with the waste heat utilization technology, and gas cascade utilization, and cold storage and conditioning technology of peak value different. Let's see the smart heating. The problems such as mismatch of thermal power demand, high heat loss in each process, low proportion of clean heating, and the lower intelligence are mainly solved by taking the heating area as the research object, combined with the livelihood project and clean heating demand. The overall solution for clean heat sources, efficient transmission and distribution network, thermostation, and so on, can provide with the integrate of electric power heating, industrial waste heating, biomass heating, and the like technologies with business model. We see the picture, they have a power system, power grid, information network, even the cloud platform. Let's see down. The incremental distribution network, it means it's an increasing amount of network. The problems such as how to complete the construction of incremental distribution network and ensure profitability in a legal compliant manner by taking the distribution network different from the traditional power grid as the research object in combination with the demand of users to reduce the price and improve the utilization rate and provide a business model solution for comprehensive energy supply with network as the carrier to improve the overall profit level. Let's see this one. The catalog is smart industry park, including 8 cases. They are block, airport, port, island, high-speed railway station, the parking, energy storage, and the smart communities, and that's the industrial parks. The fashion industry park and high-tech parks, at the energy demand such as transportation, logistics, petroleum and petrochemical, and combining the pain point and difficult of many types of energy consumption. Poor resource share among enterprises, high energy consumption, and high price. We will focus on create an overall solution of industry parks with high energy reliability, cascade utilization, and circular economy. We see this. We see the smart block in the city. The problem is the insufficient distribution capacity in the block, high electricity charges for users, and difficult charge of electric vehicles can be solved by taking the support in industrial and commercial uses, and the affluent parking facilities in the block as the research project and overall solution of low carbon electricity charge management for users. And charging service for electric vehicles is provided in combination with distributed PV power generation, battery energy storage, and AFREC. We call this electric vehicle supply equipment technology. There is one case we see. This is a PV storage plus charging integrated power station. 1.4 megawatts, the PV plus 12.7 megawatt energy storage plus 24 the AFRECs are constructed for this project and have realized local consumption of distributed power and solve the problem of insufficient regional distribution capacity. The project has realized local absorption and promote the application of green power. The energy storage system can be realized peak value price spreads arbitrage by absorbing value power and release during the peak period. So reduce the consumption cost of target commercial uses in the block. The airport. We see downside the airport case. There is one comprehensive energy supply project of Beijing Daxing International Airport. This project is adapted to roof PV and the ground PV for their own use. In addition, the ground source heat pump plus gas boiler plus boiler waste heating recovery plus ice storage can be combined to form a stable and reliable energy supply system. The total utilization of renewable energy plus clean energy can reach 12% and has overcome difficulties of high energy consumption in airports. The port, we see the port case downside, port intelligent charging for heavy truck. Intelligent charging is implemented for port vehicles, and the centralized charging station can realize unmanned operation in the full process of charging to meet the demand of 24-hour uninterrupted operation. The 5 minutes fast charging and the superpower of driving motor will effectively change the business model of port and highway transshipment logistics. The next we see the island, the sea island. This case is in microgrid project, a hybrid power generation system of wind plus PV plus diesel plus storage is adopted for this project to meet the need of 72-hour power consumption in insulated island and reduce the operation of diesel engines as much as possible, so that difficulties of high cost of diesel engines and the single energy guarantee on the supply side can be overcome. And the green power microgrid can be established. This high-speed railway station, we will see this case downside. This is a comprehensive energy supply project of Beijing South Railway Station. The technology of natural gas, CCHP, it is combined cooling, heating, and power, plus flue gas lithium bromide refrigeration units can be adapted for this project, and roof PV can be equipped to generate power for their own use, and the swage source heating pump to achieve utilization efficiency of over 90% for cooling and heating pit loader regulation. Compared with the conventional system, the natural gas CCHP can save about 4.2 million kilowatt-hour per year. This has overcome the difficulties of high energy consumption and high demand for energy in high-speed railway station. The smart community. Their attention shall be focused to solve problems of water and power supply and traffic overload by technical space carrier in confined area as the research object to promote the large-scale application of new generation information technology, the low consumption and energy-saving equipment and the intelligent equipment guide end use to optimize the energy consumption structure, increase the proportion of non-fossil energy in energy consumption, and realize the transformation of energy structure. Here's one case, smart community case. The vehicles in the smart community can realize automatic driving, and the sensors, cameras, and GPS navigation can enable electric vehicles to run safely and trouble-free. Establish a series of new smart communities based on 5G Internet of Things technology, such as access control, street lamps, air monitoring, fire service, and parking. Smart buildings, there are 7 cases, like in hospitals, schools, office building, and camp, and large business area, fixed place, and in data center. For group buildings, according to the function, of building, I mean at the energy demand such as hospitals, schools, and combine the pain points and difficulties of the poor reliability, high energy consumption, and high price. We focus on creating comfortable, convenient, reliable, and ecological overall building solutions. Let's see following. The hospital, the energy consumption in the hospital, its characteristic. The one is high energy density. The second is there are many kinds of energy demands like electricity, heat, coal, gas, steam, and water. The third is safety and reliability require high rescue. The surgery, ICU, and other departments and equipment related to life safety. The central monitoring and the like system equipment for extra and the grade 1 load need to ensure uninterrupted power supply. Its solution was built the distributed energy station to make full use of resources based on local conditions, like natural gas CCHP and the roof PV and water source heating pump, ground source heating pump, and air source heating pump, even gas boiler and electric boiler, and energy and cold storage, with energy efficient transformation of system and equipment to build a smart management and control system. Let's see in the school. Its solution, the ground sources heat pump plus surveyed source heat pump can realize centralized energy supply in the campus. The application of super energy elements, module, storage, the battery during low load at night and discharge energy during high load in the daytime to solve the problem of power supply gap. The roof PV power can improve green power for their own use. The PV storage and charging integrated station can create a green transportation system of new technology such as film press power generation trays. This, like in the picture in the middle, this is also the film press power generation trays as new things, and smart street lamps. Plus integrated smart energy management and service platform for their solution. The office tone. The solution is be focused to solve outstanding problems such as high energy consumption of office computers and air conditioning, lighting by using PV curtain wall. The PV storage and charging and source heat pump, and to provide an overall solution for office towns with ultra low energy consumption. There's one case, is a future science city, comprehensive smart energy demonstration project. In the first phase of this project, the roof PV plus ground PV plus breathing window turbine, plus energy storage system. In the second phase of project, 800 mid-cure double water storage tanks, the 15 plus 15 Newton mid-cure per hour alkaline water electrolyzer hydrogen production, plus everything, and plus 5G intelligent lamp pool, and plus management and control platform. Upon completion of this project, self-supply rate of enterprise has reached 18%, and some green buildings has been transformed and green power to the grid. The large business area, this overall solution of the energy-saving commercial complex can be provided by means of vessel, the heat pump, the energy storage system, and the intelligent management of car park. There is one case, a large commercial complex project in Wuhan, in China. The centralized cooling technology of high efficiency scroll chairs has been adopted, and a centralized energy station has been set up, and it's divided into office and commercial area for centralized cooling. They are operating the status like this. The annual operating earnings of cooling system is better than that of general industry and commercial building. Let's see the fixed place or yard. We see downside the case in China, there is one hydrogen filling station. The innovative demonstration project of Beijing Winter Olympics in this year, early, the key special project of technology Winter Olympics plus hydrogen energy traveler of the Minister of the Science and Technology. And we spec our company, SPIC, participated in the construction of integrated network in the whole supply chain of production, storage, transportation, and filling. Let's see the data center. Also, the case we see the energy station project of data center in Beijing. Based on the original configuration, the project is provided with an additional set of internal combustion engine lithium bromide energy supply system, which can utilize the peak value price spread of Beijing in the daytime. Commercial power is used for energy supply in the nighttime. In addition, natural cooling is adopted when the temperature is low in the winter. This scheme has reduced the power usage effectiveness and energy consumption cost. Let's see the next energy base. There are 5 cases: nuclear plants, the wind power plants, and the PV plants, even hydropower plants, and thermal power. Relying on large-scale energy base combined with regional load characteristics and the peak saving and frequency modulation requirement of power grid, efforts should be made to solve the painful and difficult problem, such as low utilization hours of units, low efficiency of energy sources, and balancing space and lead time, to create an overall solution of energy based with multi-energy complementarity. The peak clipping and volume filling and circular economy and other diversified development functions by combining energy storage, hydrogen energy, heat storage, and heat supply. Let's see the nuclear energy. I'm simple to state this for their solution downside, this nuclear energy. The nuclear energy plus heating, then plus the seawater desalination, plus simultaneous transfer of water and heating, the nuclear energy, plus comprehensive utilization of renewable energy for power generation, the hydrogen production and energy storage to form a diversified energy network to meet the need of electricity, heat, coal, water, hydrogen, and storage, like this. Okay, we will see the PV plus. They are focused on solve problem of ecological restoration, high PV containment rate and difficult in the transmission by taking large PV base as the research object, and develop overall solution to water, wind, and solar storage are multi-energy implementation, PV plus ecological management, PV plus ecological agricultural and animal husbandry, and PV plus industry. There's one case, it's in our company HHDC in Qinghai, the Gonghe Glatter plus PV demonstration base. We showed that. The model of growing forage grass to plant pasture in PV power station for dual use of one grass. They adapt not only restored ecology, but also played a role in prevent wind and stable sand, and become more conducive to improving the environment and grazing plus PV complementary climate. Promoted the efficient use of land resources, improve soil erosion, and increase the water conservation. The green barrier formed by vegetation improved the surrounding environment of PV power station, reduce the damage caused by a sandstorm to them, and finally achieve the goal of PV industry for driving ecological construction. We see the winter power. These problems of high power fluctuation, high wind containment rate, and difficulty in transmission can be solved by attacking large-scale wind power base. The research object and the overall solution of wind power consumption nearby and peak load saving are provided by means of clean heating of wind power, the energy storage of wind power, hydrogen product of wind power, and thermal power complementation. There's one case we study, the 100 megawatt wind farm in Dalian, in China, is equipped with a large capacity or vanadium redox flow battery energy storage system to proportion of 10% improve the capacity of wind power grid connection, and adjusted the power supply structure of grid, improve the peak saving demand. They participated in the dispatch frequency modulation and improved the power supply reliability and safe and economic operating capability of the grid. We see the hydropower. This hydropower probably supplies water in wet season, in sufficient power transmission in dry season. And low utilization of transmission line can be solved mainly by taking larger hydropower bases as the research object, and then the hydropower can be absorbed in the wide range of means of hydropower plus PV complementation, pumped water and storage, and hydrogen energy storage. There's one case also in our company HHDC. In Qinghai, Gonghe hydropower plus PV hybrid project. The Longyanxia 1.28 gigawatt hydropower project plus 850 megawatt PV project. Through the coordinated control technology in fluctuating and intermittence PV power generation is converted into stable virtual hydropower and transmitted to the grid. At a self-rotating reserve capacity, water can enhance the peak saving and frequency modulation capability. and improve transmission capacity, improve the power quality of the grid. Okay, in this part, we learned about 4 scenarios and 24 the cases. Let's see the next part. The part 4, the integrated energy business model. This picture shows the transaction relationships with connection method. There are 4 aspects we see. The first is between business and the businesses. The second between enterprise departments. The third is between enterprises and the customers. The last is between enterprises and channels. The business model is a complete efficient system integration scheme with unique core competition and sustainable profitability formed by enterprises in order to maximize value, integrate internal and external the elements, and meet customer needs and realize customer value through optimized realization forms. To put it simple, the business model is the way for the enterprise to make money. We see these enterprise cases. We know the following companies, what they have done on business. We see the company Engine and the GE, Exelon, even the Chinese companies Songgrong, Goldwind, and Huawei. We take a sample from Huawei. Yeah, that ensure investment in core competitiveness and reduce operating costs. The Huawei has fulfilled the purpose of business model innovation, tapping on potential, enhance own strengths, and improving competitive advantage. I take only this sample. This one is the business model analysis. This is means this is my map of main logic business model. The best road plan we see. Let's see. Here's the 2 sides. The one is business model. There's custom demands, the competitive, including competitiveness of energy supply price, and customer experience. And for the profit model, there is 3 elements: income and cost, unit cost, and design optimization. This is a profit factor. For the asset-light strategy and the low risk, we can use the industry fund and use the finance and lease. This analysis method is a tool. We know this SWOT. Yeah, this is SWOT. Let's see. Not more to explaining. We just see that S, the strength, is a complete industrial structure, and the second, strong team of professional and technical personnel. The third, a group of representative projects and corresponding experiences. The fourth is number of the intelligent management result of clean energy supply board. This is strength. W is a weakness. The fourth, the capability of safe customers is insufficient. And third is the projects are scattered and lack of leader business model. The internal forces are scattered and the ununiform joint force has been formed. And the lack of institutional mechanism to motivate staff. Opportunities all. As first, a large domestic market space. There is a national and local government supported industry. There are breakthrough competitive opportunities in the early stage of development. The last is the separation of transmission and distribution pricing in power system reform to give power generation enterprises the opportunity to enter the market. The strengths. The first, industry barriers are not light. The customer's willingness to accept should be constantly guided. It's difficult to make profit during the customer cultivation period. Contraction between asset heavy industry and asset light industry. This is strength. This is one tool, just the analysts we use this. There's also special investigation. This is the technical matrix table for analysis only. For example, if someone interested for then you can detail to learn it in the concrete content. We are just to see they listed their company and the project name and the project future and the current status. They compare the information. The project futures, there are six the contents, they're following up the first application scenarios and the second function model we have to learn. And the third is technical roles. We see that electricity at the core to improve energy conservation efficiency is the leading technical road to comprehensive energy supply. Choose the technical roles according to local resources and demand. And energy storage is an efficient means to utilize the low-cost electric energy. This is one advantage. The fourth, the revenue model. And the revenue model, this is alter the interface conditions where, let's see, the franchise have been obtained for the pre-project planning to buy the customer base and reduce the subsequent investment risk. Following the five, the managing model, due to the lack of the unified structure, a brand effect can't be formed. To exiting intelligent management system focus on optimization of operation side and lack of customer services. We say last six, the ownership model. It's very important. Select the partners according to the local policy. The joint venture between the developer and the local government makes the binding effect more stable so that the project can be obtain stable funds. This also the comparison of project indicator. They have the purchase price of each item. The comparison between, for example, in 2019 value and the feasibility start value of the project. The third is comparison of evaluation indicators of each project. Yeah, this is also the analysis. They have the analysis result. Through this analysis, we have the result. The result will be submitted for decision maker of the company. Okay, let's see the business model innovation system framework. We call this 3+2+1 innovation system. What's the one? It's a business model innovation center. The two is a two-stage implementation. The three is a general idea of 3T, 3S. This general idea for innovation of a comprehensive smart energy business model, 3T, 3S, we see 3T is a too big model. The second, the attractive, competitive, strategic, and tools, implementation tools. A 3S standard, principle of development. Second, as constitute the elements, the constants. The last is a sprint extension system. We will turn this concept of the business model into the concrete guide to action. typical business model, we see there are buildings and industrial park and smart home types. We see the building commercial complex, headquarter-based office, town, hotel, hospital, school, community, etc. Like these buildings included. The industrial parks, such as hospital, data center, and logistics and high-tech park, such as airport, high-speed rail hubs, and high education park and the science parks. The smart towns are being geared to construction of new urban districts, expansion and transformation of older cities, and construction of new smart cities. Those typical models is only for your reference. Let's see the competition strategies. We built the core competitiveness. It's very important. There are two aspects. One is cost leading strategic that reduce construction costs through supply chain cooperation, design optimization, economic evaluation, reduce operation costs by optimization, scheduling, and intelligent management, and establish a cost control system to create cost leading advantage. The next is the marketing leading strategy, launched brand marketing through clean energy supply and intelligent management, marketing through marketing research and pricing strategic, and establish a marketing system to create marketing leading advantage. Here is the 4 tools. We know this one, 3 book and plus more 1 model. 3 book is a business recommendation and business planning and business proposal. It's normally, yeah? And 1 model is a finance model of project economic evaluation. Collaborative promotion system, flexible utilization. The 3 book can be adjusted to meet the need of customers. The system should be used flexible and integrated to achieve great value. Connected with each other, the interlocking, the business recommendation is used to obtain the project, the proposal to guide project development, and business plan to guide project implementation. The finance model used to calculate project estimate. Here's 2-phase implementation. As 2 stage, 1 stage is form ideas, establish methods, and establish processes and build systems. The stage 2 is innovate model, to promote demonstration and sum up experience and form promotion. Next, the innovation center, we see it has a center position and 3 layers of contents. Let's see. The intelligence center, the center has consulting service platform and industrial finance integrated link center. The 3 layers have smart Internet of Things. This is an application layer. And the information layer have value-add information network. The last is a clean energy network, the physical layer. So in this section 4, we have learned the implementation business model of integrated smart energy. It has the analysis tools. We see the SWOT of framework.
Your presentation has been stopped. Can you try to share again? Mr. Liu?
Yes, yes. Now it's okay. It's coming.
Yeah, now it's coming. Yeah.
Yeah, I can't turn this the slide. If I turn to slide, they will stop. So I my course almost ended. So I'm finally we explain in this section 4. We have learned the implemented business model and the integrated smart energy. It has analysis tools of SWOT, a framework with 3 + 2 + 1 of innovation system, and the recommended business model 3T and 3S, and its practice role. And let us look about what we have known in this subject. First, we understood what the integrated smart energy, that briefly say that it can fully meet the diversified energy needs of users, innovate energy consumption pattern, and make use of difference in demands, realize the complementation of energy demands, and efficient energy utilization. The second, we have learned 4 kind of typical scenarios and 24 cases of smart energy. They are the key point of this subject. And the implementation business model we have learned. So finally, I will say thank you for your attention. Thank you a lot.
Thank you, Mr. Liu. This is very, very impressive. Another excellent presentation. Yeah, colleague, you see how integrating smart technology into our system can bring efficiency, affordability, and also reliable electricity to the end users, consumers, industry, buildings, infrastructure. So I think this is a very good examples that we have seen today with the different case studies that were presented by Mr. Liu. I hope from our side we can be able to grab some ideas here and implement in our different countries. I will give the floor to maybe some people who may have wish to ask some questions. But before then, I received few questions in the chat box or in the Q&A section. Let me put those questions first forward, and when Mr. Liu finishes responding them, then we can take a set of 2 or 3 questions, bearing in mind that we have to be mindful of the time. The first question is: Africa has a good renewable energy potentials and rich in natural resources, while China has the expertise and technologies. How Africa can leverage on China's opportunities to develop its renewable potentials and resources to meet the SDG number 7. So that's the first question. The second one is, I think this was addressed already. How is the cost of such integrated system? I don't know if I think the case studies that you have, someone want to know roughly what is the cost range of such projects. And someone said that, is it correct to say that integrated smart energy is simply a circular economy? Maybe you can elaborate more on this. So the third question, this guy is asking, how do you see the integration of renewable energy into the distribution network, the transmission network? So how do you think one can integrate renewable energy into the transmission system, the distribution network of the of a country, for example? So these are maybe the three questions that I could grab from the Q&A section. Maybe some must have come late, but yeah, let's answer these three questions. Then I will give the floor to 2 or 3 people to try to also put forward their questions. Mr. Liu, you have the floor, please.
Okay, Mr. Kobo. Let me to answer these 4 questions. For the first questions, sure, the Africa has many the potential of the energy sources of the natural sources. So we are to cooperative with China, the Africa country with China. We will to effort, we will to distribute our technical capability to you. We will through some project, through some technical communication, some program, we will to reach, we will to guide the target. This is for second, for this integrated the smart energy, their cost analysis. I think in our PPT, if you saw in the matrix analysis, if you have time to detail to learn, there is some state of the cost of the any reasons for this one. You can to learn more, because now is only 1 hour limited. If we have time, if you have any these questions, you can send my email. The question I will to respond by you. Okay. 30 is for circular the economic model. So I'm sure I will be doing this also. All the smart energy, the energy with all this one. First of all, I think the project for the power sector, we will to produce the electricity for the profit. So both. By this one, we will both to do the circular, the economic. This is also not a conflict. It's together. The last one, I think, the renewable energy is now mostly in China already to go to combine with to send the power to the power grid. So this is some technical problem in this section, but we will see, depending on the grid, the capability, how is absorbed, how is big, how is can absorb the renewable energy, like solar. You know, solar and wind air is not sometimes not unstable. Not unstable. So we will to take the measure of the technical manner and to do so to solve this one. We have China. If we are study also. We are doing this one. So thank you.
Thank you so much, Mr. Liu, for those clarifications. I'll give the floor maybe to 2 to 3 people to also put their questions forward. Let me start with Nana. Then I will move to Musa Suleiman. And then Johannes. So Nana, you have the floor, please.
Okay.
Nana, your micro is muted. Hello? Nana, can you hear me? Okay, let's move to Musa Suleiman.
Hello, good afternoon, good evening, and good morning to everyone.
Good morning.
Yeah, I think this is a wonderful and educative presentation. So we thank you very much. And I don't think I have any question for now. So thank you very much.
Okay, you are welcome. Thank you. Mr. Johannes.
Well, thank you very much. Thank you.
Can you hear me? This is Johannes speaking from Addis Ababa.
Yes, Johannes, we can hear you.
I know you can video.
Thank you for your nice presentation, and I would like to raise some issues. I mean, it was a really interesting presentation, but I have some doubts about the risks in managing integrated smart energy systems. You know, from the presentation, we see different sources are integrated and different data and even different kinds of coming technologies like Internet of Things, cloud, all these things will be integrated. So what will be the risks or the risk minimization methodologies in managing and controlling these things, the integrated smart energy system? I mean, if there is some risks, for example, for example, we have nuclear power plant, or if we have some kind of failure in one power plant or in one energy source, what will be the controlling methodologies, and what will be the risks, and how we are going to minimize that risks? This is what.
Okay, thank you so much. I think Nana, if you are back, you may put your question forward.
Oui. Là, c'est bon? Allô?
Oui, on vous entend.
Merci. Bonjour tout le monde. Je suis Madame Nana Condé de la Guinée-Conakry, ingénieure électrotechnicienne à la Société d'électricité de Guinée. Voilà. Ma question est la suivante. Il y a un passage là que monsieur le présentateur a évoqué en disant que l'énergie hydraulique, on peut transformer cette énergie en énergie renouvelable et faire un stockage. Je voulais savoir, si cela est possible, comment est-ce qu'on peut procéder à faire le stockage de cette énergie? C'était ça ma question. Je vous remercie.
OK, merci beaucoup. On va essayer de prendre une troisième question. Je vais prendre au hasard comme ça. Monsieur Lucas. Monsieur Lucas. Okay, I think Mr. Lucas is not available. So let's, because we are also running out of time. Yeah, Mr. Liu, please go ahead, try to answer these two questions. I think one was about the risks, whether you see risk in integrating different systems, and also the possibility of storing hydropower energy. So those are the two questions that, yeah.
Yeah. Thank you for the question to me. The first question is considered very deep about the risk. Yeah, sure. The management of integrated power projects, we have faced many problems. As technical problem management and the quality. The safety problem. Yeah, sure. We are to get more experience in our company. We have a large, we have a special department for all this equipment, people, management, and also the system with analysis. We use some data collection and some sensors. So we will to do all the measures we can take and will to prevent of the risk. What will happen? This is our manager, our technical man, the role, the main object. In the nuclear power station, I think with nuclear power station, they have all the system, safety system. Nuclear power, they are generated electricity for the supply to the electricity to the grid or to. But with this nuclear power station, we plus another the reasonable renewable energy plus nuclear. As now we have this on our imagined. It's not now we start this try. We will maybe in the future. Yeah. Second question for the hydropower and storage. We know that project is our pump storage, the power station. Now this is one power storage type. We use this one. Oh, now we are plus PV plus wind. It's normally now we going to the normally for the plus hydropower plus PV plus wind. This is our company's patent. Yesterday I explained this patent is one technical things. So I don't know my answer is your question. Thank you very much.
Thank you, Mr. Liu. And once again, thank you for the great presentation. Colleagues, I know there are many people who want to raise some questions, but I'm very sorry that we are lagging behind for the time. So let's move to the next presentation or next session, I think, which you may also have a chance to raise the question, because we will be discussing on the new energy storage and hydrogen production, which will be presented by Mr. Ren Wei. So let's give the floor to Mr. Ren Wei to make his presentation, and we'll have a chance to raise an additional question to him. He's also from the same company, the SPIC HSDC. So Mr. Ren Wei, you have the floor, please.
Okay, thank you, Mr. Yakuba. And hello, everyone. It's my turn to share my presentation. Sorry, wait a minute. Wait a minute. Oh, I would like to do this. Here, I would like to show. Okay, can you see this presentation? It's okay,
yes,
Mr.
Yes,
Yakuba?
yes.
Oh, okay.
Yeah.
Now I will get started. So it's my honor to share the presentation of new energy plus energy storage plus hydrogen production today. And so my name is Ren Wei, come from SPIC HHDC. And okay, so with the, we will go through 5 parts of content today. The first one is status quo and the trend of global energy development. The second one is China's energy transition strategy and the direction. The third one is application of new energy plus energy storage plus hydrogen production, such kind of system. And the fourth one is a business model of such system. And the last one, we will have looked at the bottleneck of such system. And so let's get started from part 1, status quo and the trend of global energy development. And so let's have a look at the figure at the right side. The international energy supply and demand grows steadily. As we see, they're mostly concentrated in developing Asia countries. In 2020, Asia and the Pacific countries contribute about 70% of the increase in global primary energy. But the energy demand of developed countries continues to be saturated or slightly decreased. So from the figure of primary energy growth, we can see China contributes the majority of global energy consumption growth in last 2 decades, but India will take the place of China and contribute more than a quarter of the growth of global energy consumption in next 2 decades. Since China's economic growth is gradually changing toward a more sustainable model, but China will still remain its position as the largest energy market. So now the global energy structure is subject to a major change, gradually getting rid of dependence on fossil fuel. Since the following 2 fundamental factors are driving such changes. The first one, the rise of new technologies such as PV, wind power, and energy storage. The second one, the issuance of policies related to climate change. Many countries have already issued policies to tackle the climate crisis. So in the next 5 years, we are expected to witness 2 key parity tuning points. The first one is parity between renewable energy and the fossil energy in power generation. That means the cost of renewable energy will be competitive to the fossil energy. And the second one is parity between new energy vehicles and the gasoline-fueled automobile. That means the price of new energy vehicles will be close to gasoline-fueled automobile. And nowadays, the power generation structure has been already changed. So, from the figures at right side, we can see in 2020, the global decommissioned coal-fired power station has surpassed those newly put into operation, which records the descending of the installed capacity of coal-fired power station in the world for the first time. And nowadays, our power generation structure is mainly based on coal, gas, and water. So in the future, the power generation structure will be mainly based on the light, solar, and wind power. So at the same time, economic efficiency of renewable power is reversed as well. So from the left side, we can see the LOCE, levelized cost of energy for PV plus energy storage in the United States. It could be from 23 to 36 US dollar per megawatt hour, which is less than that of nuclear power, which averaged at 105 US dollar per megawatt hour, and coal power, which averaged at 67 US dollar per megawatt hour, and really close to that of gas-fired combined cycle units, which averaged at 39 US dollar per megawatt hour. So the International Energy Agency recently launched the World Energy Outlook Report 2020, which made a scenario analysis of the prospects of various types of energy generation. But in first scenario, all states fully implement the commitments in the Paris Agreement. We just call it state policies. So the second scenario is global warming is controlled within 2 Celsius degree at the end of this century. We just call it below 2 scenario. So in this scenario, we assume thermal power output will be at its peak by 2025. And relatively slow growth shows in nuclear and hydropower output. And renewable energy generation will become the main power supply. Wind and solar power gradually dominate the power generation. So if the state policy scenario will be realized, renewable energy generation will account for 77% in 2050. If the below 2 scenario will be realized, renewable energy generation will account for 85% in 2050. So there's many new technologies are invented to support energy development, such as energy storage and hydrogen energy. Now they become the new hotspot. Especially hydrogen energy is considered as a promising future energy. It could be a clean and flexible secondary energy and an energy carrier that can exist in energy production, transportation, and consumption. So with the help of hydrogen energy, we can promote the new energy integration such as we can get a hydrogen production from renewable energy, and we can mix the hydrogen gas with natural gas, or we can transport pure hydrogen gas through the natural gas pipeline. And we can improve the flexibility of electricity power system by use of hydrogen storage, heat storage, and energy storage. Or we can generate hydrogen gas from electricity and to generate electricity from hydrogen gas again. So hydrogen energy can help us to make the energy consumption more clean, low carbon emission, and environmentally friendly as well, by means of combined heat and power, fuel cell technology, which generates no pollution, only pure water, and by means of hydrogen enriched combustion engine. So there are many methods can be used to generate hydrogen gas, but with different cost levels. So we can see the table at the right side. The highest is the electrolysis of water, and the lowest cost level is coal gasification. So according to the cost level, hydrogen production from fossil energy remains the main method of hydrogen energy production. And for more details about hydrogen production and storage and transportation application, I will introduce in the following pages. And now let's have a look at global energy transition strategy. As we know, we have already experienced two industry revolutions. In first one, a steam engine was invented based on the energy type of coal. In second one, the internal combustion engine was invented based on the energy type oil and gas. And now we are experiencing the third industry revolution, in which electric power will become the main form of energy use, which means based on the energy type of renewable energy. So in the future, energy consumption sector, electricity will account for about 50% of end energy consumption in 2050, which forms an end energy supply system with electricity as a core. And at the energy production sector, so energy production should be clean and mainly sourced from wind, light, and other renewable energies. So in order to support such energy transition strategy, many countries and cities are joining such initiatives, such as the USA, Australia, UK, and China, of course, as well. So some of them have already announced a timetable for realizing 100% reliable energy, and some of them have already realized 100% renewable electric power. Apart from countries and cities, there are many large enterprises also have announced a clear timetable for commitment to 100% renewable energy consumption, such as technology companies like Google, Apple, and eBay, Amazon. Some financial institutions like HSBC, Morgan Stanley, and UBS. Some retail and consumer brands like Nike, IKEA, and so on. So this is the status quo and the trend of global energy development. So let's move into the next page. Next part, China's energy transition strategy and the direction. But first, let's have a look at the current situation of China's energy development. Now, China is the largest energy producer and consumer, since China is the largest manufacturing country in the world. And China is rich of coal. So coal is the major component of its energy consumption. But oil and gas are highly dependent on external import. So we are facing a severe challenge on carbon emission reduction and energy security. In 2019, China's total energy consumption is equal to almost 5 billion tons of standard coal. Raw coal accounts for 57.7%. The proportion of import of crude oil and natural gas is 71% and 43% respectively. So in order to solve such problem, we are planning to reduce the proportion of coal consumption to 18.2% by 2050 and increase the proportion of non-fossil fuel consumption to 51.2%. And at the same time, we are trying to reduce the oil dependency to 50% by 2050. So at energy production sector, China largely encouraged the development of renewable energy in last 2 decades. From the figure at right side, we can see the installed capacity of solar and wind power shows significant growth in last 2 decades. And we also largely encourage the power investment in power industry chain, for especially high voltage power transmission system, which is used to support the long distance transmission of renewable energy. And we also put much effort to push the power systems reform forward continually in order to improve the macro profit of power industry. And at energy consumption sector, China's market shows also steady growth of energy consumption and gradually increase the proportion of electricity energy. But we are still facing high energy consumption per unit GDP. There's a larger space for energy efficiency improvement for us. So we choose the following 3 high energy consumption fields to implement the electricity replacements for fossil fuel energy. The first one is electricity replaces oil in the transportation field. The second one is electricity replaces coal and gas in the construction field. The second one is distributed green electricity replaces coal power and grid power in the information field. Since replacing the total consumed energy with green electric energy in these 3 fields is equivalent to rebuilding a new power system, which can take the place of oil and gas imports effectively. And the combination of the application in these 3 fields will form up a small new energy microgrid, which can be applied to schools, hospitals, and other scenarios, and finally realize the smart energy transition on user side. In addition, we are trying to maximize the value of energy storage through the cascaded utilization of storage so as to maximize marginal effectiveness in the whole life cycle of energy storage. Since the energy storage could be widely used in 3 basic fields, such as electric vehicles, buildings, and 5G plus data centers. These fields will provide about 330 gigawatts of flexible loads in 2025. And of course, at the same time, the flexible adjustment of power system need to be improved. So at the energy technology sector, in China, energy technology also shows faster evolution, which results in great cost reduction and many breakthroughs created by new cross-border applications. Since constant growth of the proportion of electric energy in the end energy consumption and green production consumption of energy are widely accepted in China, so which directed the following reconstructions of energy system. The first one is reconstruction of energy production and supply mode driven by distributed energy supply technology. The second one is reconstruction of power grid caused by the rapid growth of electric vehicle loads. The third one is reconstruction of the business and the transaction model caused by internet technology. So in China, many new participants rushing the energy field and bringing many new innovations as a result. And the popularity of energy storage and electric vehicles will dramatically change the energy supply and the demand structure in China. So China's energy transition strategy is aiming to boost the development of renewable energy, stressing the electric energy proportion of energy supply and consumption, and finally realize the deep substitution of clean energy for fossil energy. So as a production side, we largely encourage the development of clean energy, such as wind, solar, hydro, biomass, nuclear. We are planning to newly added 1.6 to 3.2 terawatt of clean energy in the next 15 to 30 years, and develop low carbon transition and the digital economy. At the energy consumption side, we put much effort to push the electric energy replacements for fossil fuel energy. For example, we largely stimulated the development of EV cars market. So from the figure at right side, we can see the number of EV cars in China shows dramatic growth in recent years. Now China has already become the largest EV cars production and sales country in the world. On the other hand, we are trying to build an electricity-centered power system as platform to integrate energy, material, and information industries in order to speed up the energy transition. So with such efforts, we are willing to reduce the unit GDP energy consumption to 0.4 standard core per unit GDP, and increase the electricity energy use to 40%. In the meanwhile, we are trying to reduce the pollutant emission to very low level, which could really close to zero by 2035. And so this page shows another energy transition target we want to achieve. The first one is we are willing to increase the share of power generated from renewable energy to 50% by 2050. And also we are willing to increase the share of non-fossil fuel consumption to 53% by 2050. And also we are willing to increase the share of electric power consumption to 51% by 2050. So this page, I would like to introduce the energy storage technology in China briefly. So there are three major types of energy storage technologies. The first one is electricity storage, and the second one is heat storage, and the third one is hydrogen storage. So as we know, the most popular one is the electricity storage technology. So in which pumped storage and electrochemical storage are the leading energy storage method, with the former accounting for the largest proportion and the later developing the fastest. Pump storage is normally coupled with hydropower station, and the electrochemical energy storage is now mostly applied for coupling with solar and the wind power station, or for powering the vehicles. As we know, the EV cars is really hot nowadays in the world. In electrochemical energy storage, lithium-ion batteries account for the largest number of items and the installed capacity, with the fastest growth speed and have become the fastest growing electrochemical energy storage technology due to the really rapid development of EV cars, I think. So in view of the cost performance, the lithium iron phosphate battery is the most widely used at present, but solid state lithium battery is a new hotspot of research and development. So in this brief, we can see that with the rapid development of lithium battery production in recent 10 years, its price has been reduced by nearly 90%, making electric vehicles and the electrochemical energy storage commercially feasible for the first time in history. And so we can see the figures below. There's a comparison between global markets and China's market. The major difference is the proportion at user side. As I mentioned before, China now is the largest EV cars production and sales country in the world. So the proportion of user side shows much larger than it's in the global market. So from the forecast, in next few years, the electrochemical energy storage market will grow by 7 times in China, and we will enter a new period of rapid development. So let's move to the next page. Let's have a look at the hydrogen industry in China. China's hydrogen production exceeded 20 million tons in 2019 with the promotion of fuel cell technology. The consumption of hydrogen in the energy field will gradually rise. It's estimated that China's hydrogen production will exceed 45 million tons in 2030 and exceed 36 million tons in 2035. And the corresponding proportion of hydrogen production by electrolysis of water will be up to 25% and 30% respectively. So at present, a certain hydrogen industry foundation is established in China with an annual output of 20 million tons, which ranks first in the world. And China's government have already issued many policies to encourage the development of hydrogen industry, such as hydrogen energy is included in the report on the work of government and the Energy Technology Innovation Plan of Action from 26 to 2030. We also set up an industry standard system. There are 122 standards in total, including 77 national standards and 40 industry standards and 5 local standards. And we also built up several regional demonstration cases such as hydrogen refueling stations and hydrogen storage project. So this is the energy transition strategy and direction of China. So according to the prediction of China Hydrogen Energy and Fuel Cell Industry Alliance, China's hydrogen demand will be 35 million tons in 2030, which will account for 5% of the energy system. The demand for hydrogen will be close to 60 million tons in 2050. Its proportion in the energy system will increase to 10%. In addition, we also set up some short-term, mid-term, and long-term objectives for the development of hydrogen industry chain, such as hydrogen refueling station, fuel cell vehicles, and fixed power stations, and fuel cell systems. This is part 2, and next let's move to the part 3. Application of new energy plus energy storage plus hydrogen production. So at first, let's us have a look at the principles of some renewable energies technologies. The first one is the principle of PV power generation. So we just use for this principle, we just use solar module to convert solar power into electric power. For the principle of wind power generation, we just use wind turbine to convert dynamic wind power into electric power. And for the energy storage principle, we just use some special materials, electrochemical attributes to store the electric power. And last, for the principle of hydrogen production, here we just want to introduce the principle of hydrogen production by electrolysis of water. We just use the electricity to decompose or split the water molecules into hydrogen and oxygen gas. So based on the principles I mentioned before, and there's we can simply conceive a prototype of new energy plus energy storage and hydrogen production. So we just simply connect the solar and the wind power station to an electrolyzer and conduct electricity generated by the solar and the wind power station into the electrolyzer. And then we feed water into the electrolyzer. The water will be split into hydrogen gas and oxygen gas. So at right side, let's have a look at the inner structure of the electrolyzer. So the outermost layer is the bipolar plate, which used to conduct the electricity current. And the next layer is the porous transport layer, which used to diffuse the hydrogen and oxygen gas. The next layer is the electrode, which used to generate the hydrogen and oxygen gas. And the innermost layer is the membrane or separator, which used to exchange the ions and to separate the hydrogen and the oxygen gas. So based on this structure, there are 4 types of electrolyzer can be used to generate hydrogen gas. The first one is the alkaline electrolyzer. This kind of electrolyzer is designed to be the most cost effective. It's technically mature and stable. Since it allows to use normal metal as its component material, such as nickel and stainless. But it needs constant load for its operation. It's not suitable for connecting with the renewable energy. The next one is the proton exchange membrane electrolyzer. We just call it PM electrolyzer. This kind of electrolyzer is designed to be more flexible and having much shorter response time. It's really suitable for connecting with the renewable energy, but it needs to use the precious metal as its component materials, such as platinum, titanium. So the cost of this electrolyzer is relatively high. The next one is anion exchange membrane electrolyzer. We just call it AM electrolyzer. This kind of electrolyzer is designed to combine the benefits of alkaline electrolyzer and the PM electrolyzer. It's allowed to use the normal metal as its component material, and it's also suitable for connecting with renewable energy, but the stability and the energy efficiency still need to improve for the future commercialization. So the last one is solid oxide electrolyzer. This kind of electrolyzer is designed to work at a high temperature environment, which could from 700 to 850 Celsius degree. This kind of electrolyzer could have highest energy efficiency than the other 3 electrolyzers by coupling with heating system. But the stability and cost efficiency still need to improve or develop for future commercialization as well. Here, apart from the electrolysis of water, there are many other methods that can be used to generate hydrogen gas. For example, pyrolysis of water. It can be connected to heat energy and nuclear energy, and photoelectrolytic gasification, biological effect, which can be connected to renewable energy. And the last one, steam reforming method from fossil fuel. So this is the most method we use nowadays. Why we are so attracted by hydrogen gas? Since hydrogen gas can be used in many fields, such as in energy fields, it can be used for internal combustion engine by mixed with natural gas, and for distributed energy station, it can be used to generate electric power. And in transportation fields, it can be used to provide power for vehicles, trains, ships, also by means of fuel cells technology, as we know. And in industry fields, it can be used for steel making. In electronic industry, it can be used as an important carrier gas, and it also can be used to make the synthetic ammonia. And in food industry, it can be used to harden the animal and vegetable fat and oil. Since the hydrogen gas is so valuable in many industry fields, so let's have a look at the business feasibility of such system to use to generate hydrogen gas. So there's a simulation case of PV plus energy storage plus hydrogen production item. Here in this simulation case, we assume we build up a 100 megawatt PV solar station and 20 megawatt hour energy storage station. And we couple them with the 4 sites of PM electrolyzer with capacity of 4,000 net cubic meter per day for hydrogen to generate hydrogen gas. So the annual hydrogen production of such system could be 4.97 million cubic meters. If we assume the price of selling hydrogen gas, which above 35 megapar, could be 4.5 to 5.0 RMB per cubic meters. So the business turnover, the revenue of such system could be 157 to 174 million RMB. So since the cost of such system could be totaled at 844 million RMB, so the investment payoff period could be 3 to 8 years. So I think using such system to generate hydrogen gas could be business feasible if some conditions could be fulfilled. So let's move to next part, part 4, business model of such system. For the business model, it's quite simple. Based on the simulation case we looked at before, we just simply built up a solar and a wind power station to generate electricity for selling. And then next to the solar and the wind power station, we can build up a energy storage system. and to stabilize the electricity from the solar and the wind power. And then we can provide the stabilized electricity to the hydrogen electrolyzer to generate hydrogen gas and oxygen gas for selling as well. And the general idea is that we can integrate the renewable energy and energy storage and electrolyzers to generate hydrogen gas. Then we can transform hydrogen gas to synthetic fuels or transform it to green ammonia, or just without transformation, just pure hydrogen gas. Then we transport them by means of shipping tanks, trunks, and pipeline or storage tanks, and to transport them to the end user in such as industry fields and transportation fields, as we mentioned before, also for heating system and power generation system. So I think with the help of hydrogen energy, we can achieve our energy transition targets much easier. There's a forecasted energy transition timeline shows some meaningful time points for the energy transition. Let's have a look some in detail here. Oh, sorry. 2030, the primary energy will be at peak. Nuclear power will be at peak. In 2033, terminal energy demand will be at peak. Natural gas will be at peak. And 2035, 50% of commercial passenger cars will be electrified. And last one, 2050, non-fossil energy will account for 44%. So I believe in the future, we will witness such milestones will be realized successfully. So let's move to the part 5, the bottleneck of such system. Bottleneck of commercial development. The first one is high cost of hydrogen production. Due to the high cost of PEM electrolyzer, since it still need to use pressure metal as its component material. The second one is unpopularized hydrogen cells and applications. Since we are still lack of hydrogen infrastructure to support for popularization of hydrogen cells and applications such as refueling station, transportation equipment. So the third one is lack of supporting policies and the industry standards. Since government and officials still need time to fully understand such new technologies, then they can issue the suitable policies and the industry standard for the development of hydrogen energy. The last one is high cost of water resources for electrolysis in drought region. So this could be another concern for some hydroponic areas. The next one is bottleneck of technological development. As we know, the electricity generated by solar and wind power is intermittent and fluctuating. Although we can couple it with energy storage system to stabilize it, but the high cost of energy storage brings us a new problem. The second one is difficult storage technology of hydrogen. Since hydrogen is really hard to compress and liquefy due to its special physical attributes, quite low density, as we know. So there's a really challenge for us to tackle this problem. I think due to this same reason, there's also technical uncertainties exist in hydrogen transportation. For example, for pipeline transportation, transform hydrogen gas to ammonia for transportation, and liquid hydrogen transportation. So there are many bottlenecks awaiting us to solve and overcome for the development of hydrogen energy in the future. So my presentation is ended here. Thanks for your guidance and support. If you have some questions, you can send a mail to me. Here's my email address. Thank you very much. Thanks.
Okay, thank you, Mr. Morin, for this brilliant presentation. Very interesting. I can see that some people have already raised the hand. They want to ask questions. I guess I have some on the Q&A section. I will maybe raise some of them. Not, yeah. So maybe the first set that we can try to answer could be, there's this question of asking what are the limitations of using hydrogen, the drawback, what is the range of price compared to other conventional resources, what are the infrastructure to use hydrogen in electricity production, transportation, and heavy industry. There's also if there is any tool that one can use for new energy storage projects, like any tool to size new energy and energy storage projects. So if there is also any financial models that you can also share in this area. Maybe the third question.
Sorry, Mr. Jacoba. I didn't hear this question clearly since the internet quality is not so good. The first question is.
Let me rephrase maybe the second question. Actually, the first question, I don't know if you can hear me now.
I can hear you now.
Okay, so the first question is asking what are the limitations of using hydrogen, the drawback, and he also asked the range of price. I know on some slide you mentioned price. Maybe you need to elaborate on that more. And also, what are the infrastructure that is needed to use hydrogen in electricity production, transportation, and heavy industry? So that's the first part of the questions. The second part is if you have any tools that one can use to size new energy projects to kind of for sizing new energy and also energy storage projects, and also maybe in some of the case studies that you present, if there is any financial models that is available to be used for new energy and new energy storage projects. So maybe let's take these two set of questions first, then I'll give the floor to people who have raised their hands. Mr. Ren, you want to address this question or you need more clarification? We cannot hear you.
Oh, okay. So
you are muted. Okay.
What the second question is also the internet not so good here. So sorry. Let's look at the.
Okay, just answer maybe the first question.
It's hedging. Okay, so I'm sorry. The first question is also not weird. Sorry, because the internet quality is not unstable here. Maybe you can send email to me. I can reply the email to you.
Okay. Okay. Anyhow, let me maybe give the floor to.
Okay. Thank you very much.
Yeah. Let me give the floor to two people who will want to also ask some question, or if anyone has the answer of this question, I think it from the participant, you may also raise your hand, and maybe we can try to share ideas and also knowledge among, because Mr. Ren now his internet is having challenges. So let me give the floor to Fatoumata Conte, then David Adewumi, and then Benedict Shinku. So let's take these three people first. I don't know who is asking question or who is providing additional input. So Fatoumata. Okay, I think Fatoumata is muted. Let's move to David.
Okay, thank you very much, moderator. Thank you very much, Mr. Ren, for your very fantastic, brilliant presentation. Mine is not actually, I wanted to ask him about two questions, but since he's not here, but I'll just throw it open. The first question concerned is presentation about the hydrogen production. In the scenario he created, he mentioned about electrolysis of hydrogen, which is one of the ways of producing hydrogen. But in his previous slide, the cost of electrolysis is much higher compared to getting hydrogen or producing hydrogen from natural gas. For Nigeria, that is our interest because Nigeria has the year 2010 to 2030 as a decade of gas. So I'm just trying to ask him, what about pyrolysis, which is the one of converting the hydrogen to, natural gas to hydrogen? What about pyrolysis? What is the cost of pyrolysis compared to that of that is generating electricity, generating hydrogen from pyrolysis from their own research? What is that cost? And the second question I would like to ask him, somebody actually raised this question earlier in the Q&A section. And the question is in his case study of using the PV, that's a photovoltaic cells, to generate energy and to store it and use it to produce hydrogen. What tool did you use for that? Because I think when you were asking the question, it's a bit different. So that's why I'm asking the question again. What tool did you use to be able to get those scenarios that I created? What particular tools did you use? Those are my questions.
Okay, let's take another person and see if Mr. Ren can come back. Benedict.
Okay, can you hear me?
Yes.
Yes, I am in Nigeria at the moment, so it's morning. Good morning, everyone. Mr. Ren, thank you very much for your presentation, which was very informative, broad, and is giving us a lot of insight into a number of things. Mine is, I asked some questions. Maybe you can take some time to give a response, because some of them you may not have immediately the information, especially those ones that border on the equivalent CO2 emissions, because you showed us emissions, but you showed us NOx and SOx emissions. You didn't show us the CO2, and the issue with the energy transition is how we can reduce the emissions to mitigate global warming. So maybe you can take some time and answer on that. But concerning the tools, I would think that the tool that is mostly used around the world today is the newest version of Homer Pro. Homer Pro, I'm sure, is a software that is very popular among people who are working with renewable energy systems, either grid connected or islanded ones. And that's the new version of it has a module for hydrogen and electrolysis. So if you use that, you will be able to get based on the location, because the business model of a system is also determined by, the macroeconomic situation of the location of the project. For example, if you are doing a project in Nigeria, interest rate, discount rate, financial information, the availability of renewable resources, and all of that would differ from a project that is even in a nearby country like Chad or Niger. So for me, I know that there's another tool called PVSYST, but PVSYST has its limitations and of course its advantages, but overall the industry is using Homer Pro. So I would think, and the information I saw from the presentation looked to me very much like something produced from Homer Pro. So I would think that Homer Pro would be the tool that can be used. I don't know if that answers. So that's the contribution I wanted to make. And then if you do a Homer Pro, because the output on Homer Pro gives you the cost of energy. So it gives you the cost of energy, and then you can work back to fit that by some kind of parameterization. You can fit it back into a proper business model for your environment. So Homer Pro will give you a range of scenarios, plenty options, but it will recommend for you the option with the lowest cost of energy. So if you have other considerations like emissions and the rest, you can then select from the options that it will give you, from the model, the simulations, and the optimizations. And there can be millions of optimizations depending on the situation, depending on the location and the particular information you are getting from that location. So it all depends on your location, and that's the beauty. That's the beauty of Homer Pro. And if you really want to go further with Homer Pro, you can do your optimization of your solar resources using another tool called Helioscope. If you use Helioscope, then you can be very accurate with estimation of your solar yield, and then you can export the result of Helioscope into Homer Pro, and that gives you a really, really accurate model, technical and business model, in fact. Thank you.
Okay, thank you, Benedict, for those inputs. I think very, very important. At least you have an option for sizing your renewable energy product. Let's go try Homer Pro. Actually, I've never used it, but I think it responds to the question that was raised. I see there are a lot of questions on the Q&A, but I'm afraid Ren is having challenge in his internet. But let me try to give him the floor again, if he can just to say one final word, if his internet will allow him just to comment on some of the topics.
So I think there are some many questions from you. It's for the hydrogen technology. It's really new technology for us in the world. There are not so many projects can compare or can to learn from the hydrogen energy. Since, as I mentioned in the PPT, the hydrogen energy now we use is normally by means of fuel cells. It's also a new technologies which used to power the vehicles. So this very famous automaker Toyota's special technology in recent years, as we know, but as now this technology is already can be implemented in many countries, but only the development countries. Since for the hydrogen production, now the major method is to use the alkaline electrolyzer to get the hydrogen gas. This is the most cost-effective ways for the green hydrogen production. So for the question of natural gas, from natural gas, we normally use the steam reforming method to generate hydrogen gas, I think. But now the cost of hydrogen production still depend on the method you use. So as I mentioned, the lowest cost is still the method to generate hydrogen gas from the fossil fuels. For the PEM, the really green hydrogen production, we know is PEM electrolyzer need to use the pure water to generate hydrogen gas, but the cost quite a little bit high, since you need to use the PEM electrolyzer. As I mentioned, this PEM electrolyzer still cost high, and so for the water you need to use the pure water. So, but the cost we cannot to see the details now, since the cost depend on the different conditions. This depend on the electricity you generate from your solar and wind power station. It's also related to the cost of your solar and wind power station, and which kind of technology you namely electrolyzer you need to generate hydrogen gas. You use alkaline electrolyzer, or you use PEM. And hydrogen gas also facing some problem for the transportation. Nowadays, only the Japanese companies realize the liquid hydrogen gas transportation. So for the most cost-effective ways to transport hydrogen gas is to transform it to ammonia. So we can see some projects in the UAE or in the Egypt. So they generate hydrogen gas and transform to ammonia, and since it's much easier to transport ammonia than the liquid or the hydrogen gas alone. So I think there's many problems here. As I mentioned, many bottlenecks we need to solve to utilize the hydrogen energy. So some uncertainties still remain to use the hydrogen energy. So it's dependent area which kind of project or which kind of system we use to generate hydrogen gas. So this is quite complicated, I think. Maybe we can exchange some opinions so in details one by one. So this now it's really a little bit hard to, it's need time to speak it in details. So this is my opinion. So, thanks.
Okay, thank you so much, Ryan. Thanks, colleagues, dear participants. I know that the subject is very, very interesting, but I'm afraid we have exceeded the time that was allocated to us for this particular session. And it's the end of the today training sessions. Tomorrow will be the last day, the day number 4. We will have 3 topic to be presented tomorrow. We'll have module number 8, which will be on the current situation and trends of photovoltaic. Module number 9 will be assessment of distributed solar PV potential. That will be presented by World Resource Institute. The first presentation for tomorrow will be made by Power China Chongyang. And the last topic will be module number 10. Will be focusing on renewable energy potential and NDCs in some African countries, which will be also presented by World Resource Institute. I know that we for tomorrow, for the 3 remaining sessions for tomorrow, we'll try to get them and upload into the same link before the end of the day, so that in the afternoon, by tomorrow morning, you get them. So with that, I thank you very much. Let's meet again tomorrow to complete this very, very interesting training. And be assured that we'll keep in touch even after this training with our partners from China. So with that, I thank you very much, and have a very good day or very good evening or night in China. Thank you so much.
Thank you, everyone.